If you're looking for some information on Industry 4.0 or modernizing your organization, some transformation, potentially building an agile factory, you come to the right place because that's what we're going to talk about today. I am Michael Askins, architect and technologist, and this is IT Pro Tech Talks. Chris, professor, how are you?
Doing great. We just started the new semester, so things are alive and well, moving around.
That's brilliant.
Yeah.
Love it. One of the things that popped in my head is, we've been sparsing some of these out to get people to come back for more. I got to get that form built up because, we have, this episode as our, the framework of Industry 4.0, but then we're going to potentially have some additional guests and topics to talk about. I'm wondering, should we put that form out for someone to get that copy of that book?
Yeah, so I guess it depends, right? Do we want to have our magic word today and then give it that option, or do we want to wait till I think we've got at least one more show that we want to put out, or should we finish it now?
So how about we talk about that offline and make people come back and listen to the next show to find out. See what I did there?
I like it. Let them figure it out.
Yep.
That's a real cliffhanger.
Yep. So, on that note, we do really appreciate you watching and listening. The stats on the audio podcast are still wonderful. We're still growing the video channel. So we appreciate you all out there, hitting that subscribe button, watching it, not just like kind of watching for 3 seconds and clicking off, because that doesn't really help grow the channel and get, in front of people's eyes. Those of you who have put a good meat of watch time in there, the analytics are coming back pretty decent. So we appreciate you immensely. I know you hear that from pretty much everybody that does YouTube, but there's a reason why. There's a lot of work and a lot of time, a lot of effort, and sometimes money to get things out there just because we feel it's good messaging. So getting that feedback is brilliant. And interact with us. I know on the YouTubes, there's not much interaction, but there is a lot of interaction. I get people flicking me directly on LinkedIn about some of the stuff we've talked about. Let's move that to a public place. We do have a Discord server. I might publish that out here. Really wasn't using that as much, but I think it's a great place to go and pick up some more interaction or FaceTime.
For sure, yeah, and I mean, it's the same thing as the students in my class, right? Put it out to the group, because I can almost guarantee somebody else the exact same question you have, or the exact same thought or comment, right? And then that becomes a communication, that becomes a conversation, So I put it out there for the masses.
Absolutely. Well, let's dive right in. Let's just go headlong into Agile Factories. What does that involve? I mean, I've had customers that are, manufacturing and have factories of various kinds, and everything from medical equipment to pieces for cars to plastics to the widget that you buy on Amazon. I've had several different types of factories or manufacturing that I've worked with. What makes an Agile factory?
Yeah, and it's interesting because when we had our special guest Jeff Winter on a few weeks back there, we talked a lot about a lot of areas that lead up to the digitization of factories. We talked about process improvement, process enhancements, having better visibility as to what's happening on our shop floors and in industry. And when we start talking about Agile factories, it's really the how. How do we get that information? How do we analyze where processes may be inefficient, right? And in the majority of cases, the only way to do that is to collect data, right? And so Microsoft sees obviously a booming opportunity when it comes to modernization of factories, and factory of the future is something that gets thrown around. Yeah. Obviously, Industry 4.0 is a collection of these, I guess, methodologies, as well as deployments, implementations, however you want to put it. And really, it's all about how do we help organizations to embrace digital transformation, make their organizations more efficient, driving innovation, improving our partnerships, right? And really begin to thrive in the newer eras of advanced manufacturing and automation. And so what we'll talk about is sort of the 6 key areas that this can be bucketed into when we start talking about Agile Factory. Of course, it starts with digital transformation, right? And
Absolutely.
it's all about an organization's ability to, it's not even as simple as going from analog to digital, right? It's really upending your organization. I mean, we've got many customers who've been on digital for a really long time, but it doesn't do justice to the ability to not only embrace newer technology, AI, optimize those areas of the organization, but it's all about a culture shift, right? And we've talked about that in previous episodes, how to engage our employees better, how to engage our customers better, and those types of things. And really, in order for these organizations to be able to adapt to the modern world and come along, digital transformation comes first. Digital transformation starts with the ability to analyze data. And if you can't analyze the data, it's really hard to understand what changes need to be made, what processes can be improved, and all of those areas. So how do we do that, right? And when we start talking about Agile Factories, it's all about the ability to connect our manufacturing equipment with a stream of data and almost consciousness about what's happening within that equipment, within the production floor, being able to grab real-time data and glean insights from that data to be able to enhance operations, to be able to reduce downtime, for the ability of optimizing our production, optimizing our various production lines, right, and everything that's happening within the organization. And then it's taking that data from sensors within the plant, within the manufacturing equipment. In the book, I use an example of a freezer where, if you've got an industrial size freezer that's storing a lot of perishable goods, and you see fluctuations in temperatures throughout the day, well, the door is probably being open and closed. So you have to set tolerances in there. But the only way to do that is to be able to analyze the data. Otherwise, if that freezer door gets left open and that freezer heats up overnight because somebody forgot to shut it,
it's a bad day.
You're going to have some problems, right? Yeah. And so, really we have to figure out, how do we get that data, right? And so that's through real-time data and insights. That's through analysis, and that's the ability to capture that data and then visualize it, right?
Yeah. So on that point, it could be anything from IoT sensors centralizing and being ingested. I had a project where some of the actually input sensor was a human being who had had a tablet, and they were doing their checks, and all that went into some of the analysis too. Though we want to try to automate as much as possible, but there's security and safety checks that need to be done. If you had that person with that tablet and they saw that door open, they can mark that, and you can compare that against the temperatures. But then there's those other things that are not necessarily sensors, but it's interpretive data. Again, on that same project, they used a lot of camera imaging to determine what was going on. with the stuff that was coming off the line, and I'll keep it generic just because, you know, NDAs. So they had cameras, and if something was out of tolerance, you know, it removed it from the line and it recorded it and it sent it to you know, a database, and then you can look at all that stuff and do that analysis you're talking about. It's just amazing the amount of touch points a product has in a manufacturing process. It's amazing, you know.
And really, you know, you mentioned IoT sensors. You know, this equipment, I mean, you think of you know, a jet engine, or you know, a locomotive engine, or, you know, some of these industrial engines, you know, that are being designed and developed. They have hundreds of sensors in them, right? And so if you're talking about a piece of manufacturing equipment, you know, depending on the industry you're in and all that, I mean, you could have, you know, manufacturing equipment that's, you know, 50, 60, 70 feet long, that, you know, is taking the raw materials and building them up. You know, you could be, you know, doing all kinds of operations, heating and cooling, and
pressure,
pressure, molding, right? All that kind of stuff. And in order to track all that information, be able to pull all that data appropriately, you need to have some kind of sensor. You need to be able to have that data. And quite frankly, you know, there is a case for a certain number of individuals collecting data on the floor manually. But, you know, for this type of stuff, it would be far too
automatic,
difficult to capture, right? And really, a lot of it comes down to throughput, right? I mean, if we were able to slow down our production lines and say, well, you know, we're going to cut production in half today, yeah, maybe we can keep an eye on it manually.
Sure.
But the whole idea here is that we need to produce as much as we need to produce, right? In order to keep up with the market, keep up with demand, whatever the reason, you know, there are certain schedules that we have to follow. And the best way to capture that data, you know, a lot of times we've got manufacturing in far reaches, right? You know, certain areas where maybe internet isn't great and things like that. We start to introduce what we call edge computing, right? And when we talk about edge computing, it really allows us to have some type of device, computer, Raspberry Pi, whatever, right? That's able to capture that data and quickly analyze what's happening. We're not talking about anything super sophisticated, but, you know, when we start talking about tolerances, you know, if that freezer is supposed to be at negative 27 degrees and it heats up to 30 degrees, right? We're probably going to be outside of that tolerance, and there's going to be a problem, right? Yeah. And so we're not looking for this to be, you know, a super sophisticated, you know, AI model that can identify, you know, to the slightest little detail or where there might be a problem, but more as just an information collection and analysis sort of on the fly quickly. And so, you know, these edge devices, like I said, they could be as simple as a computer. Microsoft has Azure Stack Edge, which is a relatively, you know, small but hardened device to be able to send all that data to, you know, for that quick analysis. And then ultimately it sends it up to Azure for further analysis, maybe storing and things like that. And really, the benefit of that is that, you know, you're able to reduce the latency it takes to get that information feedback, that trigger, that notification that you have a problem, right? It enhances your organization's responsiveness to be able to say, holy cow, we got to close that freezer door. And it's kind of a cheesy example, but hopefully it's simple enough for everybody to know. You know, I mean, even your refrigerator at home beeps at you when you leave the door open for too long.
Yep. You just sparked a synapse in my head. I worked on a project.
Synapse?
Nice. No, unfortunately, I am wired different, but not that different. Yeah. So it fired something in my brain. We worked on a project a while ago where we had towers and pads where we had the small, lightweight Cisco switches in there, and you can run containers on them. And one of and we had to specify those because it was a collection device. So the switch that connected all the devices together also had a small little bit of compute in it too. So like to your point, it doesn't necessarily have to be this massive, 6-figure thing that you're plopping, 400 times around. It could be something simple as a switch that is container enabled, or Raspberry Pi, or insert device here.
Yeah. And the whole idea here is, like I said, we're reducing that latency that it takes to get that information. But then also, if the internet goes down, right, you've got these places that are in far reaches. We're starting to see 5G get used in applications where, maybe there isn't cell service, but, we can somehow figure out, private 5G and things like that options in order to enhance the internet connection. But it's not a given in a lot of situations, especially in manufacturing and things like that. And that was interesting. My light just shut off. Must have died. And really, when we start to kind of look at it, like those are the things that help us to drive that real-time data processing, the analytics that goes with it, and it's at a device level, right?
Yep.
And so, to take that a step further with our IoT is in order to understand what's happening on the shop floor. So if I think of a grid of a factory and I've got, 1,000 machines on the shop floor, and I've got, some that are robots that are able to build this stuff together. Some are just contained within the manufacturing equipment. I can use what we call digital twins to get a better understanding of what's happening within each of those devices. So if you think of a digital twin, it's essentially a virtual replica of the physical assets and the processes that are happening on the floor. And so we can put in a mock patch maybe into our IoT device for capturing that information that we can, analyze to figure out, are we going to break something by doing this patch or adding this software? Are we going to have problems with it? We can have a model of what that shop floor looks like. We can have all of our 1,000 pieces of equipment laid out on a screen, and it can tell us if a piece of equipment is down. We can click into it to say, why is it down? Is it down for maintenance? Is it down because there's a jam? Is it down, for whatever reason? Or maybe it's yellow. Maybe there's a warning, right? Everything else is green. The whole idea is that you're simulating, you're modeling, and you're optimizing with that digital representation of what's happening in the physical world, And so we're seeing a lot of adoption of digital twins from customers to be able to have that sort of that virtual replica of what's happening.
It's the ultimate what if, right? What if I increase production and my belts are running at 4x the speed? What's the temperatures of those bearings going to be? And you look at the sample of what it normally looks like, not just a generic bearing. You're looking at the data of your bearing, right? So that's the difference. Is like, there's modeling. Modeling has been around forever. You can model something but that's just, hey, best case. But if you're taking your data and putting it into that model, you're going to know that bearing's going to fry out at 4,000 widgets a second, as opposed to the 2,000 it's supposed to run at, right?
Right. And we'll talk about that more specific here in a minute. So don't jump ahead on.
Yeah. Sorry.
And well, I mean, the other thing too is really that the practical application, right? You've got a foreman, you've got a manager that's walking around the shop floor. They're making sure that their team is doing what they need to do, making sure that they have all the problems solved that they, that pop up over the course of a day. We've got a bad batch of raw material. This machine is cutting a little strangely today, whatever it happens to be. And then we're able to, like I said, we can put that on a digital display. I've got a customer, they build industrial equipment, and they've got digital dashboards all around their factories that can say, a piece of equipment's down. It can show the product, or the production lines. Are they ahead of or behind schedule? Those types of things. And it really allows us to kind of do a further analysis if we need to as to what's happening on the floor. The big thing here is, I think near and dear to a lot of people, though, is how does this get secured, right? And how do we ensure that it's reliable, that we're getting good data from our equipment, and because this becomes so critical to our decision making throughout the day, really just ensuring that we have the uptime that we expect. We're avoiding any unexpected downtimes, because that's very, very costly. I once had a customer that said if a printer on a production floor went down, it cost them $50,000 an hour, right? And these are big industrial printers, and and that's just one customer, that's just one factory floor. So you start to do the math in your head, and that can be pretty crazy,
Or if it's somebody in a data center accidentally hits that plunger for the emergency disconnect, and
Sure.
all the connected systems go down.
Right.
Ask me how I know.
We need like a commiseration podcast.
Yes.
So obviously we need to ensure that we're putting a lot of security measures in place. We're trusting the data that we're coming from the devices. We're trusting that the devices themselves are trustworthy, can't be hacked. One of the challenges that we have with IoT in general is that a lot of times they're made in a black box, and a lot of times they're made on commodity-based hardware to be as inexpensive as possible, and you don't know whether it's going to be supported or not, right? So it's kind of a guessing game at times. And so we want to make sure that we're using devices that are trusted. Microsoft had the HCL forever hardware control list.
Yep.
Compatibility list, right? Hardware compatibility list, right? Similar to IoT, right? Where you ensure that the devices that you're using, the sensors that you're using, the data collection areas you're going to be using, the edge devices that you're using are all going to work, in concert to ensure that we have proper data flow. And really, it's all about sort of compliance. Following along with industry standards, making sure that regulations are being met. We're tracking the data we need to, in cases where we have to, and really ensuring that we've got that privacy integrity that goes along with it.
And smattering Defender into the IoT space too, as well, so you can fully adopt a zero trust security posture.
Right.
Yeah.
And really what that leads to is actually one of my favorite discussions that I have in my class even, and it's around predictive maintenance and the value that comes from predictive maintenance, right? Connected devices enable the predictive maintenance to help industries prevent any kind of equipment failures. Now, there are numerous examples, but we'll go back to our freezer, and if we've got another sensor on our fan, and the fan has suddenly kicked up another 100 RPM unexpectedly, and the temperature is stable, right? So there's no explained reason as to why there's a problem. Well, the fact that that's kicked up another 100 RPM and we're seeing that tells us there is a problem, right? And so we're able to figure out what that is, and whether we gracefully take that offline. Hey, we got to lock this freezer. We can't allow any air to escape because we have a problem. We need to get into it. We wait until that day's production is done, perhaps, to be able to get into it. Or, we have a maintenance schedule coming up where we can take it offline without interrupting the production process, right? This allows for, obviously, the saving of cost. It allows for scheduling, so that when we bring folks in to do maintenance, whether it be an outside vendor or internal team, we can schedule it more appropriately, again, without having any kind of downtime, which is obviously critically important. I mean, the amount of money that costs organization that will cost organizations when they have that type of downtime, it's just astronomical. and I use the $50,000 an hour printer example, but we've got a big piece of equipment that goes down. I mean, it gets a lot worse, right? I mean, we're talking millions, tens of millions at times, let alone the issues you might have with delivering the product on time if it's a custom order for a customer and they're expecting it or something like that, right? I mean, we've done everything to strip out waste within the production process, lean manufacturing, all of these types of activities to make sure that, that we're delivering what we need to on time. But that doesn't always factor in if there's downtime in our equipment.
Yeah.
Right. And so, well, sorry.
I was just going to say, one of the things with the predictive maintenance systems too is it allows you to, compare the mean time before failure of a piece of equipment and be smart. And, like you mentioned earlier, gracefully, this fan is down, it increased because of bearings fried, but, oh yeah, by the way, we know that capacitor pops after, 20,000 hours and we're on 19,000 hours. Throwing those 1,000 hours away is just worth it because of the cost to keep that running.
Yeah. And when you think about it, you've got 1,000 pieces of equipment, they've probably got tens of thousands of parts, inside of them. You've got normal maintenance that needs to happen. You've done 10,000 cycles. The belt that you mentioned earlier, it's time for it to be replaced. And so, from a maintenance standpoint and a shop floor standpoint, now you can much more easily plan out the next couple days, weeks, months, however long it takes. And you've got a very set schedule. Hey, we know this machine is going to be offline for this week because, we've got to go through it fully and replace all the belts or, whatever. I mean, there are just endless amounts of areas that, we could analyze and go deeper on that. So
mad respect to the guys keeping that stuff running, guys and girls keeping that stuff running,
for sure.
That is crazy skill to be able to do that kind of stuff and be able to, make sense of the chaos of machinery.
Yeah. I mean, it's like expert level Sudoku, right? I mean, you got to make sure everything lines up perfectly so that, you don't have any waste, right? You don't perform any of the maintenance either too early or too late because again, that all costs money, right?
Yep.
And so we, in my class, we actually have a lecture about this and the value that this brings. And in that particular case study, it's around Frito-Lay and Pepsi and, how if they can keep their operations running, the value that comes from keeping those operations running, for however long that they need to. And we have constant cycles, we have 24-hour factories and all that. So if you can coordinate that clearly, cleanly without downtime, it makes a big difference.
Yeah, it's huge.
So, and then of course, tied to that is any kind of anomaly detection. We can look at process optimization as a result of that, right? And then all of this, all of the data, all of our analysis, it all starts to lead toward AI, right? We start to figure out, okay, now we're going to make more predictions. We're going to go even further with our predictions to be able to, satisfy demand. When are we going to run out of the raw materials that we need, right? What are our inventory levels for even just maintenance equipment? Do we have the right number of belts? I don't want to buy too many if I don't have the appropriate storage, right? So I want to buy the right amount to be able to ensure that, I'm maximizing the shop floor, the space, the inventory holding, the warehouses, all that. I want to make sure I maximize and optimize that space so that I'm not wasting that space. But at the same time, I don't want to over or under order any of those supplies that I might need, whether, they be parts or they be belts or they be, raw materials, right? And so that's where we start to plug in AI and it gets really exciting to work with. And then after we've been able to collect all this data, we start to look at what if analysis, right? As you mentioned earlier, what if we do this instead of that? I mean, there's a book that we all got in MBA school called The Goal. And it all talks about bottlenecks and how do you eliminate bottlenecks? Well, you can't eliminate bottlenecks ultimately. There's always going to be a bottleneck. There's always going to be some place in your factory that it's going to slow things down. Once you fix that bottleneck, there's going to be another one that slows you down, right? Mm-hmm. And so it's kind of one of those things where, you can't remove bottlenecks, but you want to optimize based on what the demand is, right? You don't want to overproduce either, because then you might be wasting it. Could be perishable. Could go out of style. It could be, could be replaced by, some kind of disruptive incumbent, right? Or entrant into the ecosystem. So many different things, and really, it's all about, sort of maximizing the value you're getting from your equipment, maximizing your throughput and productivity, and minimizing your costs, right? Yeah. I mean, ultimately, that's as an organization, aside from social responsibility and just being good citizens and taking care of our people, ultimately, we're here to make money. We're here to, cut out costs as much as we can. So, really, those are the 6 steps when you think about it. You think about that move to digital transformation. You think about collecting real-time data and analytics and gleaning insights from them. You talk about the bringing all that data to the edge of your factories to be able to do that quick analysis and then send it up to the cloud for the deeper long-term analysis. We want to make sure that our systems are secure and reliable. We want to be able to perform predictive maintenance. We want to make sure that our equipment is running optimally, that our schedules are running optimally. We're not bringing in too many people, for scheduling wise, and folks being on hand that just won't be able to do any work that night because there isn't enough work for them to do, and scheduling that out properly. And then finally, optimizing our processes to make sure that we are running as efficiently as possible.
That is really succinct steps. I can never say that word. I don't know why I even have it in my vocabulary. They're really pointed steps. And, for the non-technologist listener, I just want to kind of put in your mind, these steps are achievable by organizations of all sizes.
Absolutely.
You reference use cases from Pepsi and Frito-Lay, and you and I both have had customers throughout the years that with names on buildings that are like massive moving organizations. This is not out of the reach for the regional or local manufacturer. Right. In fact, these tools are there and affordable to make you as competitive as possible so that you might even get into arenas that you would once think that were out of reach. I think the whole of the series we've talked about, we try to talk in concept, not saying, hey, go get we did actually say get a HoloLens, but we're not saying go subscribe.
That's just cool though. I mean, who wouldn't want one, honestly?
But these things, these concepts are achievable. And it all comes down to, do you have the mentality to say, okay, this is where we're at, this is where we need to go, and how do I get myself there? How do I transform? How do I innovate my processes? How do I reconfigure and reimagine some of the things we do? Because as well as I do, there's some of these manufacturing, like I got a customer that's over 100 years old, and they're still doing largely the same thing for the past, 50 years.
Right.
So the movement of that is very slow, apparently, right? But can you just start with gathering data and looking at it? Start with let's get the mindset, but then let's just start looking at the numbers and see, because then it could be, once you see the numbers, it's hard to not, it. You can't unring that bell.
Absolutely. Right? Yeah. That's why I love data so much, right? Because it's tangible. It's there, and you almost think about it as a growth mindset organization wide, right? Yep. That ability to imagine what is possible. And, to your point, it's all about scale, right? You can start small, you can build, you start to see, I love the snowball effect, right? I love starting small, getting those quick wins, building it up, helping it grow. And then, once you start saving more and more and more, it's like a runaway train, it's a snowball rolling downhill, and it just becomes, just a great opportunity for an organization to really, grow and innovate and all those great things. Maybe you're manufacturing and you're saying, oh, my equipment's old. I'm lucky that I even plug it in, right? What do you mean connecting it and collecting data? Well, the best part is there's a ton of opportunity to retrofit this stuff, to be able to program it. I mean, they make kits to be able to learn vibration patterns on equipment, to understand what's happening.
Optical equipment to see tolerances.
Right. Yeah. All that kind of stuff. I gave a talk not too long ago, and somebody asked me, well, could you use cognitive vision to look at a meter on a piece of equipment to be able to say, if it's in green, it's good, but if it's in red, it's bad? Well, the answer is yes. You put a pretty simple camera there, and you set up your custom vision session. You train that model to say, if it's over here, it looks good. If it's over here, it's not good, right? And it's relatively straightforward, for even the most rudimentary of equipment. And so it's a ton of opportunity for organizations, new and old, and really, when we start talking about how to maximize what your organization can do, for its customers, its partners, its employees, these are some of the steps that really help an organization get as much juice from that squeeze as they can, as they say.
Absolutely. And this is the point in the show where I put the disclaimer. It's not my normal disclaimer. This is the disclaimer. This is addictive. And if you've never gone through it before and you start doing this and you start seeing what that output is and the difference you're making in the lives of the, floor workers, first line workers, to knowledge workers, to the bottom line of your business, it's addictive. And you see that in certain people with a growth mindset, with innovation and in their heart, where they say, they want more, they want more, they want more, because there's so much room. So that's not my normal disclaimer. My normal disclaimer is this show's for entertainment purposes. Right.
Well, and the other thing too, I just realized is we never actually gave the word, right? So no. I think that our word of this show should be maintenance, right?
Yes.
We talked about that so much. So,
agree.
For this show, I think we'll use maintenance for that.
Yeah, I'm with you on that one. 100% agree. Well, on that note, I think we're at time. So we're going to wrap up this show. Again, thank you for being a listener and or viewer. Hopefully you're both. There's enough content in here where I find myself going back, post-production listening, but then I was like, oh, that's really good. We touch on stuff in such stream of thought a lot of the times that, I listen to, and I'm not just making to try to pad my stats, telling you all to listen more than once, but I'm just saying, listen more than once. Sometimes you glaze over.
It's even running in the background. It all helps.
That's brilliant. Well, thanks, Chris. As usual, great show today, and we will see you on the next go around, listeners and viewers. That being said, have a good night. Bye.
Great catching up. Take care.